Now let's focus on another example where we're graphing a quadratic by finding specific characteristics. So we're given the function f of x equals a negative 3x squared minus 3x minus 1. It's quadratic, so we have an x squared. So we look at our first coefficient, it's negative. If it's negative, that means it's going to go downward, so it's concave down. If you're afraid you're going to forget, just put since a equals negative 3 is negative. Then we want to find the vertex. So again, the negative 3 is our a value. The second negative 3 is our b value. So the h value of our vertex, negative b over 2a. So that's the opposite of the negative 3 over 2 times the a value, which is also negative 3. That gives us a positive 3 over a negative 6, which reduces to a negative 1/2 for our h value. Then for our k value, we're going to plug in that negative 1/2. So we get a negative 3 times a negative 1/2 squared minus 3 times a negative 1/2 minus 1. So let's simplify the k here. We have a negative 3 times a negative 1/2 squared is a positive 1/4. Remember, you have to do your exponents before you multiply. Negative 3 times a negative 1/2 gives us a positive 3/2 minus 1. And then starting again, negative 3 times a positive 1/4 gives us a negative 3/4. Plus, I'm going to change that 3/2 to have the same denominator. So that is 6/4. Forgotten how to do that. Multiply top and bottom by the same number to get that 4 in the denominator. And same thing with the minus 1. We're going to write that as a negative 4/4. This gives us a negative 1/4. So we have a vertex of a negative 1/2 and a negative 1/4. So for the axis of symmetry, remember that's always the x coordinate of our vertex, which is a negative 1/2. So we get x equals negative 1/2. Axis of symmetry, you have to have that entire equation. For our y-intercept, remember our x is 0. We have to find our y. So we're going to plug in 0 for our x. We get negative 3 times the quantity 0 squared minus 3 times 0 minus 1. So all of that gives us a negative 1. So we get a y-intercept of 0, negative 1. So a couple of things before we even look at the x-intercepts. We can plot the points that we know so far. We know the vertex is at negative 1/2, negative 1/4. So if we were to zoom this in, negative 1/2, negative 1/4, our vertex would be roughly there. And then they also said that we have a y-intercept at 0, negative 1. The nice thing about the axis of symmetry, let's draw that dotted in red, is if we find any point on one side of the vertex or the axis of symmetry, then we know we're going to have a point the same distance on the other side of the axis of symmetry. So whatever this distance here is of 1/2, we're going to have the same distance here of 1/2. So our parabola is going to go down like this. Now that doesn't seem very big, but that's going to help us in this particular example with E, x-intercepts. Well, again, we know x-intercepts. We're going to have x and a y for 0. So normally we would plug in 0 equals a negative 3x squared minus 3x minus 1, and we'd have to solve for that. We're going to learn how to solve those quadratic equations in the next section, 3.2. So in the meantime, you can use your calculators like we did in earlier sections. Just put that in the y equals, graph it, see where it hits the zeros. But in this example,
there are no x-intercepts
because our vertex landed below the
axis
and we knew it's opening down. So just by that graph alone, we know there are no x-intercepts, no zeros. And then the last question is intervals of increase and decrease. Again, remember, intervals of increase and decrease are only in terms of x values. Well, I know that this function here is increasing all the way up to that point right there. So that means all x values up into that -1/2 will give me increasing y values. So intervals of increase will be from -∞ to -1/2. We're going to always use x values for both increase and decrease because it's a function. The y's could repeat, but the x's won't. Okay. So from -∞ all the way to a -1/2, our function is going up left to right. It's always read left to right. Well, then it starts to decrease at that -1/2 going to the right. So we will say decrease from a -1/2 to infinity. So again, from left to right, it's going down everywhere from that -1/2 out towards infinity. It's going to keep going down and down and down and down and down. Now, notice when we wrote it in interval notation, the -1/2 is in parentheses for both. At your vertex, which is your max or your min, it is neither increasing nor decreasing, right? It's a turning point. So you do not use a bracket stating that it's still increasing at that value. We'll use parentheses always.